Hi, everyone. Thanks for joining today's session. My name is Marco Guire. I'm the research director at Covetal, and I'll be hosting today's webinar. For those who are aware, today's topic, we're going to be talking about daylight and other 3D analysis within Covetal. We're going to go through how to set up a model, how the different analysis are calculated, how you can leverage them in your design process, and we also have a couple of case studies that we're going to showcase in today's presentation. If you'd like a copy of this recording or a copy of the presentation, always feel free to reach out to our support team. They're that blue circle on the bottom right-hand corner of the app, and they'll be happy to provide you with a copy. This presentation should take about 45 minutes, and then at the end, we'll open up the floor for any questions. So if you have any questions, feel free to start dropping those below, and then we'll address them at the end of the webinar. For today, I do have a PowerPoint slide. We're going to be going through that and then hopping back and forth between the actual platforms so you can see how certain analysis should look, how different things can be conducted, etc. So thank you again for joining, and I'll go ahead and share my screen. Awesome. So a quick look at today's webinar. We're going to be doing an overview of the performance analysis, how to set up the 3D analysis, the different things you need to know about our calculation method, the different types, and then how overall 3D analysis can help you out. We're going to go first into breaking down daylight modeling and understanding how STA, AAC are calculated, how to read those maps, and how they affect your building's energy. And then we're going to look at the other 3D analysis tools like the shadow tool, radiation, sun hours, COVID occupancy, and quality views. We also have some rule of thumb slides talking about how energy or daylight affects energy and the correlation between the two. And then finally, a couple of case studies that you can check out on our website, but we're going to see a master planning that used 3D analysis, as well as a renovation project that was one using Covetal for 3D modeling. So first things first, what is performance analysis? So any of you have already started using Covetal or are using any other platform out there that uses 3D simulation, cloud computing, things like that. What performance modeling does is it uses a 3D model to test, analyze, and iterate in order to improve your building's design. Our goal is to make performance analysis earlier, more accessible, so that more projects can conduct them and have an impact that can hopefully bring down the cost of the building, but also improve the building's efficiency, reduce carbon emissions, all those other good things that we're trying to make possible with Covetal. One thing to note about performance analysis, it's always an approximation. It's trying to get, based on the information you can populate into the tool, an idea of what the overall impact might be. We can never exactly predict what's going to happen, but the goal is just to get enough information so that you are making an informed decision, so you can have real-time insight on the different parts of the building. There's a lot of different areas of analysis. You can see this kind of spreadsheet here, things looking at energy, water, ecology, wellness, equity, predictive analysis. For today, we're really going to be targeting on the wellness, looking at different things that improve occupants' comfort, like SCA, ASC, quality views, so on. One thing to note also is when exactly are the 3D building performance analysis conducted. So this is a really great graphic, always like showcasing. It's from the Architect's Guide to Building Performance. It's an AIA publication, but it really highlights when certain analysis is done and who's responsible for those analysis. So when you would typically conduct early or 3D analysis like daylight, etc., it's typically done in the earlier stages, schematic design, design development, also in the earlier stages of construction document, making sure that you've kind of dotted all your I's, especially if you're pursuing any sort of certifications. Those are the areas where they can be conducted. And of course, also architects are capable of running this analysis. Sometimes you hire outside consultants. Sometimes you have the in-house green team who can conduct these analysis. But these are really analysis meant to be done as you're making decisions about siding, massing, orientation, the facade strategy, shading strategies, and then eventually into material specification about what materials are you selecting, their reflectance properties, their coloring of materials, all those kinds of things. Within CoveTool's platform, most of our 3D analysis are going to exist in the analysis tool. So right now we're going to be talking about 3 different analysis types. We have SDA, daylight modeling, ASC, glare analysis. And if you're not familiar, we'll go through what the SDA, ASC stands for, how they're calculated, all those kinds of things. We also have quality views, the shadow studies, the radiation map, COVID score, and also the sun hours analysis. I might have skipped including that here. Here's a snapshot looking at a tower project in San Francisco, and just shows you all the different analysis that you can generate. These are all the 2D map analysis, but you can also do envelope studies, site studies within CoveTool. And there's a lot of different benefits that you can get from generating 3D analysis. They can be really helpful for communicating your design concept, identifying what strong points you might have, identifying areas of potential, like do we have a lot of high radiation in the area? Can we use that for passive heating in certain spaces, or just improving natural daylight within spaces where we don't have to depend so much on active systems for lighting, things like that. And of course, the better you can design the daylight and quality view of a building, the more we can have reduce the energy consumption, because that's a lot of utility bills you won't have to worry about because you are taking advantage of passive strategies through the 3D analysis. 3D analysis can also help with other areas. So of course, if you're pursuing green building certifications, almost every major green building certification has a section for 3D analysis, whether it's looking at daylight modeling, illuminance studies, shadow studies, radiation, thermal comfort, all those kinds of things. They all talk about it, and CoveTool, of course, can help with the documentation and pursuing a couple of the different credits within the certifications. And of course, earning a certification for your project can improve the market value of the project. There's a lot of different incentives, both local, state tax incentives for it, and also just shows that your client is committed to improving your occupants' comfort and making a green building. Also, one other thing about running analysis earlier on, in this survey taken from the Technology, Culture, and Future of the Architecture Firm, which is an AIA publication, 2 of the biggest profitability and efficiency indicators that were showcased in the group that was surveyed. One of them was able to showcase strong management skills, and the other really key details being able to show real-time insights. So teams who are making changes to the building, or quickly iterating, or trying to figure out what design option they want to go with, being able to run these different analysis and showcase in real time what the impacts of these different decisions will mean, and helping make the more informed design decision. So that's really one of those other benefits. Cool. So with that introduction, let's go into actually setting up a 3D analysis. So a 3D, I've talked a little bit about what the performance analysis is, and that's just kind of a computer model to recreate the conditions of your environment. But when we're specifically looking at a 3D analysis, we're trying to figure out how to analyze a 3-dimensional surface and also output a three-dimensional image, which will help communicate some sort of spatial data. So we're going to go through the different steps and components of a 3D analysis, but it's slightly different because it is taking into account all of the different environments, reflectivities, materialities, positions, all that kind of stuff that will help calculate and impact the different metrics that we're trying to record within a 3D model. Specifically, when you're talking about CoveTool and how we calculate the different 3D analysis, the calculation method we're using is ray tracing. There's a couple of different methodologies out there. You probably heard of something like the Radiance engine and others, but what we're specifically doing, and this is also how we do it a lot quicker and faster than everyone else, is that we're doing a forward ray tracing method, and we're taking information that we collect from your weather file, which is going to be the sky dome, and then all the recordings across the sky patch on the sky dome. and we project that information into your model in order to figure out how much lux is a surface receiving, what materiality that surface is, and if it's going to bounce light further into the space, so we can measure more incidence, or just how much is a certain part of the building absorbing a certain amount of light, things like that. And that's how we're going to record these analysis. You can see a couple of different diagrams here. You can see how that information is casted onto your building, and then how certain things are being recorded at certain levels or layers within the building in order to determine the different metrics we're going to be going through. But this is how we're doing it. And of course, everything is cloud computed. We're running it on a lot of different servers. So we're running all of your analysis simultaneously. So it doesn't take up too much space or computational power in order to generate each of those diagrams. If you've ran 3D analysis tools elsewhere, each floor could take you, 5, 10, 30 minutes, depending on the complexity and level of detail you've modeled in that space. But we can typically do the whole building in under 5 minutes. If you haven't had the chance to set up a Cove Tool project, this is going to be really crucial to understand as to how we generate and set up your 3D analysis. So the 4 minimum requirements to set up a 3D model, or to set up any analysis in Cove Tool, are going to be knowing your building's location, the building geometry, the input standards, and also the calculation method that will help us run any of your results. And once we have those 4 inputs, we can set up the energy model, the daylight model, load sizing, system design, etc. You can see those on my PowerPoint slide. Each one of these are also helping populate things that we need for the 3D analysis. So when you enter in a building location with Cove Tool, that helps us select what weather file is nearest to your building. And with the weather file data, that's going to help us recreate your environment. So that's going to be helpful for the energy analysis, but also to generate the sky dome, which is going to be used to project all the different conditions that will generate your 3D model. With building geometry, of course, whether you import that geometry via plugin or you create it from scratch in the drawing tool, the environment, all those different components is going to help calculate self-shading, reflectivity, how far deep things can penetrate within the model, stuff like that. Import standards based on what calculation method we're following, or whatever standard we're following for that analysis, we're going to be making assumptions about material reflectivity and things like that. So those are the standards we're following. Of course, the calculation method for the 3D analysis, we're mostly following things that are dictated through LEED. And you can see all of those kind of explained in our help articles in more detail. When we get information from your building location and from your geometry, the data that we're going to need to create in order to run the 3D analysis is really a series of raster data points and vector data points. Raster data, if you don't know, hopefully these diagrams kind of make sense, but that's the information that's going to help us create the 3D component of the model, which is things like I need it backwards actually. We need to create the vector data, which is going to 3D points. So that's going to include things like the points, the areas, the volumes, the meshes, the objects, any sort of derivative of a surface, like any of the actual 3D component. Like if you were to touch that surface, what would you feel? What are the distances between those points that helps us recreate the actual model? And then things that are applied and information applied to each one of those points within the model are the raster information. Things like textures, colors, transparencies, reflective properties, and a lot of other material properties that currently we don't take into account in Cove Tool, but can also impact your building's performance, like material properties for heating, for shadow, or for a couple of other these. But it's just something I wanted to showcase to give you some context about what we're generating. For the vector data of information, of course, all the geometry that we need is primarily going to come from your model. So exterior walls, windows, floors, roofs, those the minimum requirements set up within your building. But you can also include other categories like interior walls, skylights, shading devices, building heights. I think our most recent Revit plugin has a couple of new categories, which will all be taken into account when we set up your 3D environment. And also with GovTool, with your building address, we also create a 3D environment using an OpenStreetMaps API so we can create that context. And later when we talk about the shadow tool, we'll be talking about how the context impacts your model. Other information that we need to run the 3D analysis are the rest data for the material properties. So right now we follow a fixed methodology according to LEED. So these are properties that we can assume for most building types. Right now we don't allow users to currently edit or change the reflectance properties. It is something on our roadmap. It will cause your analysis to run slightly longer. But right now, every surface has a certain reflectance percentage, and that percentage is used to calculate, what is the level of light that's being able to enter our space. So if you have a purely mirrored surface, 100% of light is able to bounce off that space and continue at the 100% radiation it initially received. But if it hits a 40% reflective material, then 40% of its initial power is now gone. So it's only proceeding at 60% radiation. So those materials are taken into account in order to calculate things like lux values and also any thermal properties that can help that will impact your building's energy results. But here's some of the assumptions that we make, and they are all fixed for now. And of course, once we have those components, we can help run all the 3D analysis. So location will help us select the weather file as well as generate the 3D maps and all the context buildings throughout your site, uploading your geometry, and then the fixed values for reflectance. That's going to help us create the actual model. We'll be measuring everything, and then the methodologies per analysis type that's going to help us calculate what your final results are for each model, as well as the maps. Yeah, so let's start going through the different analysis types. So the first analysis that we're going to be talking about is daylight. And there's two daylight analysis that we have in GovTool. We have SDA and ASC. So we're going to go those in a moment. But before we do, just want to talk about what is daylight modeling. Daylight modeling is the practice of using 3D simulation to predict the pattern of controlled natural daylight to illuminate a space inside of the building. Like I've mentioned, daylight is information that we need to get from your weather files. So every single building will have a unique daylight map because of their environment and because of the geometry. If you create the same building, you place it in different locations, they should also have different daylight maps. But if you have the same building and semi the same location around the same area of where the weather file was generated, then you might get similar daylight maps. And we have a couple of different tools that can help you calculate daylight. We're going to go through those in a minute. Daylight is an incredibly important analysis to run. It really surrounds itself around the productivity, happiness, and well-being of your building occupant. There's a lot of research out there about the benefits of making sure you design for a well-daylit space. And also, it's a great marketing tool. So if you are running daylight analysis, you can't necessarily pursue certifications or other standards which might be financially better, or not financially, but recognized through certifications for the project. You can still use the data analysis to improve daylight and then use it as a marketing tool for the client or for your own website to showcase the quality of spaces that you can create. One of those kind of leveraging tips we like to showcase. The SDA analysis itself stands for Spatial Daylight Autonomy. If you haven't ran this analysis before, you're not familiar with it, how this analysis is conducted is that we take each floor plate within the model, and then we divide it into grid points. And the size of each grid point is determined by the grid size input. The smaller the grid size, the more grid points you're going to have in your daylight model. Therefore, the longer it's going to take to calculate the daylight percentages and generate the daylight map. One of the other inputs that you do have the ability to edit, so almost every reflective material property is fixed, but you do have the option to change glass transmittance. So based on the visual transmittance of your glazing objects, you can enter in a percentage, and that's going to help us also figure out how much daylight is entering the space. And based on how much daylight can enter the space, we record that amount of lux, and lux is how we measure the quality of daylight. How much does it hit each one of these grid points? And based on the amount of lux it receives, that's going to give you your lux per hour. And then for calculating SDA, we're specifically looking for the percentage in the occupied hours where we're receiving over 300 lux. So 300 lux is what we'd consider a well daylit space. So if you're currently in an office building and it's pretty bright outside and you can turn off your electric lights and it's still considered a well daylit space, that's around 300 lux. And we only measured daylight for SDA during operational hours, and the typical operational schedule is 8 a.m. to 6 p.m. That's also not something that can be changed. And also the lux, the daylight map, or the plane where we measure the analysis, is 30 inches above the floor. So that's the work plane height. The smallest grid size that you can currently calculate a daylight map in is 2 by 2, and that's about the average radius of a person. Or also, if you have like carpet details on your building, you can typically see them in 2 by 2 grids. That can give you an idea of just how much is each part of the building receiving daylight. We also have this legend down here. This is something that's uniquely Cove Tool. We showcase in 10% increments how much SDA is that part of the floor plan receiving. So if it's receiving over 50% SDA, so for over 50% of the occupied hours, you have sufficient daylight, which is over 300 lux, you're going to get a grid point that's colored yellow, orange, red within that level. If it's not receiving sufficient daylight for a majority of the occupied hours, then you're going to get this darker coloration. But that doesn't mean the building isn't is completely dark. It's just not as well lit as what we're looking for SDA. So if you have a lighter blue, that's pretty ideal, especially if you're designing for schools, hospitals. That can be really difficult to get sufficient daylight in. And that's just one way to visually indicate if you're receiving sufficient daylight. The other analysis, so that should be ASC, but the other 3D analysis that we have for daylight is ASC. ASC is annual solar exposure. So it's the same calculation method. We take every floor slab in the building, we divide it into grid points. You tell us how big each grid point is, and then we record how much lux does each one of those grid points receives. For the ASC analysis, we're looking for overexposure, or where the space is incredibly bright that your occupants would be uncomfortable. And in this case, we're looking for over 1,000 lux. So that's typically where you're in a situation where it's really bright, it's really glary, you close like blinds, or it gets really hot, you take off your jacket, things like that. And that's what we want to design against. And also the time period that ASC is looking for is a little different. Instead of 50% of occupied hours, it's looking in increments of 250 occupied hours over the year. And then looking at the legend, in this situation, any grid point that is not having a glare issue or does not have over 1,000 lux for at least 250 hours of their occupied schedule, that's going to be colored green. So all that space is comfortable. And then where you start having issues are in the yellow, orange, red. And if you have over 1,000 hours where you have over 1,000 lux, that's an incredibly bad spot for glare. So those are spaces that you want to start addressing on your building facade. So you can see this the S-shaped building. That looks pretty comfortable. A lot of green, a lot of yellow, the yellow, red, orange. In those spaces, we might want to figure out any shading strategies to reduce the amount of glare, but we also want to go back and forth and make sure that our shading strategy that reduces glare is not overly blocking the amount of daylight. So then it becomes a balancing act. You can see that this is a Georgia Tech building that we helped on. Most of the building, since there's smaller openings, there's not a deep daylight penetration, but in the areas where we do have large openings, we do have issues with glare. So we want to think about higher performing glass, things like frits, or overhangs, fins, anything more architectural. One other tool that we can help, especially in the early stages before you have a more detailed analysis, is our facade tool. So before you've gone through the process of modeling your geometry, so you know what the glazing distribution, window wall ratio, anything like that is, this facade tool can be incredibly powerful to pinpoint what's going to be the most beneficial strategy. So how this facade tool works is it's a generic room. The geometry is not reflective or representative of your building. It's just a generic room. You can control what direction it's facing, northeast, southwest, or any of the 45-degree increments of that, like northeast, southwest, etc. And then you can play around with the window to wall ratio, window height, window width, distance from ledge, window seal, and then also properties, shading properties like glass transmittance, overhangs and fins, as well as the depth and number of overhangs and fins. As you're running through the facade tool, this is instant rapid feedback. So it lets you know this is going to be a beneficial strategy, or what kind of STA, ASC quality these spaces will get. And that should help kind of inform what design you want to develop in more detail through your other modeling platforms like Revit, SketchUp, Rhino, especially if you have to do a whole facade design. And you want to know that the design you're going to model in more detail is already kind of providing the impact you think it will. So facade tool really helpful in those earlier stages. And we have a couple of case studies where we showcase folks who knew they're going to do a 30-40% window to wall ratio. They wanted to look at large openings, slits, curtain walls, things like that. And they just wanted to be confident about if they're going to explore shading or dark VT, which one was the most beneficial, so they didn't have to waste their time doing all the modeling and help save on those billable hours. Yeah, so one other part of the tool, so I currently don't have any slides for it, but the climate report is also a really beneficial place to get information about daylight and geometry design. So here's one of the analysis. This is looking at the radiation sky dome, which is part of the Tool climate report. And it's using the help diagram to indicate what's going to be the most beneficial strategy depending on where you have a lot of radiation on the model. If you have a lot of radiation coming from lower angles, so it's typically when you're higher on in the northern hemisphere, shading strategies that can be really beneficial include things like frits, fins, vegetation, dynamic glass, overhangs. If you have a lot of radiation coming from the middle angles, so that's kind of 45 degrees from the horizon, things like fins, overhangs, light shelves, shadow boxes can be beneficial. And then if you have radiation coming from a high degree angle, so it's like directly above you, if you have really bad noon to 2 p.m. sun, you want to try to avoid things like direct skylights, low roof insulation, but explore things like cantilevers, overhangs. Here's some diagrams over here. The clear stories, solar pipes, solar tubes, things like that. So this can be really helpful for just informing early stage analysis to figure out how we can get daylight penetration depending on where beneficial versus non-beneficial sun's coming from. Also, as you're generating the different daylight maps, you can also help reveal certain strategies that you might have not thought about. So this is coming from a study looking at the 2030 palette, which is a bunch of different strategies based on your climate zone, and then intersecting them with the daylight analysis that was done in Facade Tool. So what kind of daylight quality did we get depending on the orientation of the building? And then could we explore things like sun spaces, skylights, or if we couldn't have daylight coming directly into the space, is there a way to absorb that energy from the daylight, which is basically radiation, and then store them for heating through tomb walls or just thermal massing, basically that idea. And then as you are generating the different daylight analysis, of course, there's a lot of ways to create different reports. So we're going to be going through this case study later. This is a renovation for an Atlanta library and showcasing the before and after doing all the daylight models. There's a lot of potential for prototyping, iterating, and just getting immediate feedback on top of energy, which might not be super different between different models where you're making small changes, but daylight can be a huge help determining what is the option that you want to pursue or further develop. So we're going to come back to daylight and just pull all these different concepts together. But before we kind of go to that section, I just want to talk about other 3D analysis that we have in Cove Tool. So two of the key analysis, and these are analysis that are only conducted on the building envelope. And also if you do have an outdoor floor or topography object, we will conduct these analysis on those objects. But we also conduct radiation and sun hours. So radiation is looking at intensity of sunlight on the building envelope. Of course, you all know sunlight is basically just energy, energy that provides light to a space, but energy still also provides heat. So just looking for any areas on the building envelope where we're exposed to a lot of radiation that could become a heat issue or a potential area for opening up for glazing. The sun hours analysis is, instead of looking at intensity, it's looking at duration. So how long are we experiencing certain conditions? And based on the duration of those conditions, is there something we want to take advantage of? So in certain buildings, you might want to place additional glazing, or you want to put certain programs adjacent to the spaces where you just have a long duration of solar exposure in those areas. I've talked about, I just mentioned a couple of takeaways, but for radiation, it can help also pinpoint what kind of performance and products that we want to select for the building. So if we have a lot of really bad radiation in parts of the building, we want to improve the performance of the glazing. We want to increase the insulation on certain products or take advantage of thermal massing properties of different elements. Can also really be a great indicator of PV placement. So currently we don't have a photovoltaic calculator or just a potential solar energy that calculator within Cove Tool, but the radiation can be a really good indicator of what might be the best location for that. And yeah, for the sun hours analysis, all about building occupant, maximizing daylight access. In areas, there's certain cities across the country that have a maximum window to wall ratio. So if you do have to budget where you're going to place and distribute all the glazing, making sure that it's going to receive the most amount of outdoor glazing, things like that, the sun hours analysis can be really helpful. The next 3D analysis type we have is quality views. So this one doesn't have anything to do with measuring daylight, but just completely about the 3D environment and what we have visible. So kind of moving away from daylight, but just talking about more of the 3D analysis space. So how this analysis works, you can see here, it's another ray tracing method, but this time it's casting a ray from within every grid point within the floor plan. And then just looking for any glazing objects. So once it finds a glazing object, it starts to measure, am I encountering any obstructions? Can I extend all the way to the sky? Do I have any obstruction before I can reach any window? And then based on those different conditions, we're going to be able to calculate 90-degree sight lines, sky and contacts, and or obstructed views. And of course, this analysis type, this is one of those lead credits that we've been able to help automate and then help document for the certification process. So here you can see the model. It's the same building, but with the 4 different view types. One of the view types, which is total quality views, it just lets you know across the different spaces which one or what part of the building had majority quality views. Yeah. And of course, this analysis can be really beneficial just with the kind of how dramatic this image is. It just showcases the importance of making sure your occupants have view access to the outdoor spaces, and there's a lot of research and cell potential with designing for quality views in a building. Next, the analysis that we have is the shadow studies. This is also something that you can generate within the 3D analysis. This is the only tool that's point in time. So all the analysis types that I've been talking about so far have been annual metrics, but with the shadow study, you can actually, with sliders, control when a certain analysis or shadow is being casted for the day and also the day of the year. You can see some different analysis types. We have this just showing that over a typical day, the shadow being casted. You have the traditional shadow study, which is looking at different seasons and then overlaying the shadows over the same location. So you can see where areas are going to be typically casted in shadow versus spaces that are going to be more open. You can include different types of obstruction. So in this bottom left-hand corner, we have a school project. It was a small K through 12 or K through 6 in Atlanta, Georgia, and then just looking at the shadow study for trees and how that was going to affect the space. And of course, like I mentioned earlier, with your building location, we will automatically populate your context. It's a half a mile of context. It's coming from OpenStreetMaps, which is one of those large satellite platforms out there. And you can always update this information. You can edit, delete any of the context buildings before you run your analysis. And then we do have default materiality reflection for all those surfaces. So all these different context buildings, the ground, and then your own geometry is taken into account when we run the different analysis types. And also, since this tool is completely interactive, in a moment, I'm going to hop over into the tool and just showcase the actual environment. You could also do things like screen records. You can download images for a presentation, whatever kind of thing you're trying to put together, story you're trying to tell. That's something that we can do within CoveTool. And then finally, the last 3D analysis type that we have is one that's very different from all the other analysis types, but it still uses your 3D environment to generate the map. That's the COVID occupancy assessment score. This one's really unique because it's a building analysis that came out of the pandemic, and it's looking at floor layout and density of objects within the building floor plan to determine whether a space is safe or unsafe to safely occupy. A space is defined as safe when it has 0 obstructions within a majority of its social distancing range, which is about a 5 to 7 foot radius. If it encounters any sort of obstruction, then it's going to decrease how well that space in the floor plan is considered safe to occupy. So the more obstructions, the harder it is going to be to safely social distance. This is an analysis type that actually came from the AIA as far as like response to the pandemic and figuring out how we can improve building types. And it was a really kind of quick feature that we pushed out. So it's not necessarily used often today. I think most projects that have the most applicability are school projects and also healthcare projects are typically the ones looking at this. Here you can see different applications. So just different things. These are all included in the help article around the COVID occupancy score. So you can see how they're used, and up here is kind of the best showcase of it. It's different building layouts for classrooms, and then figuring out like which one was the safest to occupy and what kind of layout worked best based on the layout of desks within a room. Well, so those are all the 3D analysis types. Before we keep moving forward, I just want to showcase them inside of the actual tool. So like I said, once you successfully set up your project, you'll get access to the 3D analysis page. It's the 4th tab on the navigation bar on the left-hand side. You can come into the tool. Here you can see the OpenStreetMaps. If I turn off the map, you can actually see the radius around the site. So that circle, our building right there in the middle. I'll turn off some of these elements, go to the SDA analysis type, and then we can start seeing the different views. So this is the U-shaped building. If you've attended the Revit webinar, this is the one that we're typically looking at. And then you can see in this analysis, we did set the grid size to 2, which is the smallest size. We had a generic glass, so it's just stayed at 0.65 visual transmittance. And then everything else is as is. In the 3D environment, you can always toggle elements on and off. So I'm just going to look at the floor plan. So I'm going to turn everything but the floors off. And also I'm just going to look at floor 1 by 1. So 2D, north arrow. That's the first floor. You can see anywhere where we have red, orange, yellow, that's where we have sufficient daylight. You have some of those darker blue areas, so that's also receiving a lot of daylight, but just not as much to be considered well daylit under SDA. And then spaces that are not having that much daylight penetration, we can turn on the interior walls to kind of get a better idea of what that looks like and what might be causing some of those obstructions. 2nd floor, 3rd floor. And then of course, if you want to download any presentation images, you just use this camera icon to download a PNG, or you could just screen record, screenshot, whatever you typically use. SDA, ASC, you can toggle between the different analysis types. Here's that shadow tool. I'm going to go ahead and turn on the other elements so they can all be taken into account. Change time of day, hour of the day. It's got radiation, all that context taken into account. Sun hours, COVID also within the floor plan. This doesn't, the COVID analysis really works best when you import furniture. So that's one of the optional geometry categories. But right now, pretty much everything is sufficiently good to occupy. And then views, different types of view access. And then based on your facade design and your floor layout, we can figure out like what space actually has sufficient views and which ones doesn't. Cool. And the other tool I want to showcase is the facade tool. Where's that? Here it goes. Facade prototyping. So we're looking at the south-facing room right now at 65% window to wall ratio. We can play around with the height, width, anything like that. You can add overhangs. You can see how that's going to immediately impact the STA. These are really deep overhangs, so just go down to 8 inches, 31% SDA, 29% ASC. Still really high ASC, so maybe you want to put down the glass transmittance a bit. Then you can go, once you kind of figure a good spot, that can be a product you start looking for, or just like this condition, you can start modeling in more detail in your third-party modeling platform like Revit, SketchUp, wherever you do it. Yeah, cool. So those are some of the modeling tools. Back to the presentation. Daylight and energy have a lot to do together. Here's a quick slide that we got from the weather file presentation and looking at passive strategies, but This is just looking at the climate files, the temperature and humidity, and how that kind of indirectly impacts energy consumption with the utility bills for gas and electricity. And of course, the same situation is happening with the 3D environment. There's a lot of different types of comparisons you can do. So like SDA and EUI is always going to be a really great one, looking at different energy options based on configurations or facade options, and then how much daylight penetration you get through each of them. Tool does have SDA and ASC, as well as energy included in the comparison report. If you haven't done a comparison report before, it's on the, it's in the projects dashboard. You're gonna go to your projects. I'll just pull up a massing study. I can click each one of these check boxes, click compare, and then you have the comparison report side by side, and then just a couple of different categories that you can look at, like energy, glazing ratio. I don't think I ran the SCA analysis for these two models, so here it's not showcased, but for the ones you have, it will be included. Yeah. Yeah. Some of the other impacts that you can see when you're running energy analysis and a daylight model, orientation is going to be a really big part of that. As you rotate your building, daylight's going to come in a different direction, but also other things like the radiation, heat gain, heat loss, all that's impacted based on the orientation of a surface. The larger the orientation, so if it's over 45 degrees, the bigger the impact will be. The smaller the increments, the less likely you'll see like a major change, especially in the earlier stages. As the project gets more complicated and more detailed, those orientation and energy models won't be as common, but you should still get an idea of what the metrics are. So if you're trying to reduce energy, increase daylight, orientation is going to be a big part of that. Glazing property is another really big part that's going to affect both daylight and energy. Sometimes shading is the only thing an architect does in order to reduce energy, especially if they don't have mechanical engineers involved earlier on. It's going to be really important that you take all the different factors of the building into account when you're running analysis. So we haven't talked anything about any of the internal loads, like equipment, lighting, things like that. They should be taken into consideration, but also just glazing properties can be really beneficial, but it really depends on where you're located. So we have a more in-depth article you might want to check out called How Does Shading Impact Design Performance? It's in our help center and really talks about all the scenarios, things that you need to know about, like how does shading really affect my model, and then how do things like building typology play a role in determining the energy impact of my shading and glazing strategies. And then finally, window to wall ratio is another type of energy analysis and a type of study that a lot of architects tend to do. And sometimes you won't see major differences between energy models when you have the same window to wall ratio, but you're just distributing it in different ways. So in this analysis, we have the same building, but we have glazing, or we have a window to wall ratio for 40% in each of these options, but we've distributed them in different ways, like large opening, punched out windows, and then larger ribbon windows. The energy performance was incredibly similar across these different designs, but they had radically different daylight results. So you want to balance both of those and figure out what would be the most efficient design, making sure you're just not focused on one, but looking at all the different results you can get in CoveTool. And finally, last thing I want to showcase, we're a little over time, but we still have 10 minutes. I just want to run through two quick case studies. So the first one is a master planning project in Pittsburgh. This is a project that was actually done for a competition. It includes 8 different buildings for a new office park in Pittsburgh, and a couple of different types of analysis were conducted to inform what the benchmarking, and then of course building targets were going to be for each one of these models. Here's the shadow study. The building massings were already determined, but we're just trying to establish other information that would be helpful to inform the rest of the design process. Here you can see the sun hours analysis and also just a quick street level site study, just looking at tree distribution, what that's going to do at the eye level down here. When you import a topography or a site object, it's always great if you can break it up into little sections so you can get more of a detailed map. I think this is just one big box, but they did break it up into little grids later on. Here's the daylight analysis, glare analysis. This was done for each one of the buildings to set a benchmark for it and a target. And also just looking at, again, radiation and sun hours. As well as energy benchmarking. That's something you can do for each project, but I'm not gonna go into too much detail here. So I just wanted to kind of give you like an idea at a different scale, but the other case study that we want to showcase today is one of our more popular ones. So this is the Atlanta Central Library renovation. If you haven't heard about this project before, the Atlanta Central Library is was the last building of Marcel Burr, who's a famous architect. He was a brutalist architect. And one of the key attributes of the building was that it was a pretty heavy concrete block with not a lot of natural daylight coming to the space. The space was built back in 1980 and has since not been really well received by the people. The project for a while was being talked about being demolished and replacing it with a new library, but a couple of city folks and architects wanted to save the project with the renovation that would increase the quality of life within the building, and a lot of that was just through running daylight analysis, opening out the facades, things like that. So that's what this project's looking at. Here's the baseline design. So this is what the original building design was back in 1980, all the way up to 2022 or 2020. So we had the existing building performing at a 49 EUI. That's how much energy it needs per square foot per year to operate. It's still more efficient than the national average, which for a library project was around 98 EUI. But if we really wanted to consider it high performance, we had to get it much closer to the 2030 target, which is 20 EUI. But the daylight STA for this baseline building was at 4%. So incredibly low, very little daylight actually was in this space. And you can see from some of the photos, some of the facade design, what that looked like. First analysis that was conducted was the climate report. So looking at different possible benefits that can be taken. We had the sky dome where we're looking for beneficial radiation, where we could possibly open up the glazing to allow for more passive heating, and also just good natural daylight that's not going to be too harmful because of glare overheating. And also in the psychometric chart was another analysis you can create. The most beneficial strategy for a project in Atlanta was taking advantage of internal, or it's supposed to be a solar heat gain, non-internal heat gain. So just taking advantage of more sun in the space. So that's what they were looking at. There's a lot of other upgrades that they were exploring. They definitely, on top of opening up the facade to allow more daylight in, they had to re-explore materiality within the space, and also knew that they were going to do a lot more LED lighting to make the space a lot brighter. So you can see some of those examples. Based on the decision to open up the south facade for a lot more glazing, you can see some of those before and afters, the 1980 design versus the 2020 renovation proposal. We saw a 13% increase in the total glazing area with the new design proposal for just opening up the glazing. Since it was still in the pretty urban area of downtown, we didn't get too much increase, but 6% from, or 10% from 4% was pretty great. And also through a lot of the other renovations they were doing, they had a 30% EUI reduction. But you can see before and after, and just a lot more kind of SDA coming in. Here's a snapshot of some of the other analysis they did. So the radiation, sun hours for the space. Don't need to talk about it. And here's a little snapshot of the 3D environment. So just to the south and southeast of it, we do have a lot of large towers since it is in downtown Atlanta. But still, just to improve the quality of life, include quality views. Quality views was another analysis that they were doing just to make sure that we could showcase the benefit of the spaces. So we saw 12%, 13%, 25% of different types of quality views across the different parts of the building. Here's the final design. So the renovation proposal was accepted. The project got $50 million to be renovated. Here's what the snapshots of some of the final design looks like. So just some of the windows that they added. They also added large skylights to kind of bring into this atrium of the library, and it's a lot more bright, colorful, all that kind of stuff. And of course, with the renovation, a lot of did energy modeling to improve the efficiency of the design. Here's that final report. So yeah, really great project. There's a lot of more information that you can find about it. They also did a Arc Daily interview about it and how daylight analysis kind of saved this project. So yeah, that's everything that I had to showcase today. I know that's a lot of information. We went through a lot of analysis types, a lot of scenarios where you could apply it. I see a couple of questions. I'll answer those, but if you guys have any questions, feel free to start dropping those in. And if you have to hop off, thank you for joining. Hopefully you found a lot of information in it. And if you want the recording, it will be posted on our website under training sessions. And if you want to copy the presentation, just reach out to our support team. I'll let them forward it. All right, so first question, what engine do you use to perform simulations regarding daylight for SDA and ASC? So we use the forward ray tracing, and we follow the lead definition for SDA and ASC. So a combination of those helps us calculate it. And then we also are validated against radiance. So even though we don't use the radiance engine, we do make sure that we're within the correct, I'm sorry, I have to find it. This one. We're within the what the expected results are if you were to use radiance. Yeah, and there's also, I think there is a case study in our help articles showcasing Cove Tool versus what was the old radiance tool? The one before Climate Studio. You can check that out. Next question. All right, cancel it's live. Do you know when your website cove.tools.com will be available? It's currently down. Oh, I haven't heard any information about that. The website should be cove.tools. I don't think it's cove.tools.com. So you might have typed in the incorrect information, but I think the website's up. I usually get like an alert if anything's happening with it, but I think you should be able to access it and check out information about the platform. Next question. Does it take into consideration porosity of trees in the shadow study? So the shadow study, the detail that we casted in is pretty big. I think it's using a 5x5 foot grid, which is that grid. If you turn on the grid icon under element selections, that's the level of detail it's capturing. So I wouldn't say it's going to capture porosity within trees. We also currently do deciduous trees. It's just going to be fixed geometry, so you can run a daylight analysis or a shadow study with bare trees versus trees with full vegetation and just see the impact. But I think the porosity of trees is too small of a detail to take into account for our current shadow tool. Yeah, I think you would need a much more detailed tool to do something like that. But that at the building level, it's probably not something that we would be adding to the tool for a while. Yeah. Next question, can masses be used in the early stage phases to compare energy models? A lot of times we don't have windows, walls, floors, or roofs models designed in concept stage. Yes. So one thing you can do is create your geometry within our drawing tool. So if you have a pretty good idea of what that geometry is going to look like, you can go ahead and set up that massing. I'd recommend, so I think if you do have a massing of your building in the earlier stages, you at least have the walls, floors, and roofs. You might not have any windows for that concept design model, but if you just draw a 1x1 roof object, kind of place it wherever you want in the space, it should be sufficient to import or go through the different analysis stages. And since you have such a small area of windows, it shouldn't affect any of your results. But you can do that. And then also, if you go to our help center, help.cotool.com, you can just type in massing studies and see what I'm talking about. Like how to do that, different types of comparison studies. But yeah, that's totally possible. Next question, how can we simulate solar envelopes? I'm not too familiar with the concept of a solar envelope. If you're talking about like a second skin or like some sort of louver system or even like a shading system that has a really detailed pattern, there is a way to simulate it. It doesn't require you to model that object exactly. So for example, frit is a really complicated type of object to model and then simulate within a daylight analysis. So if you can calculate what kind of percentage coverage the area that's going to block daylight is going to have for that surface, you can actually just recreate that as like a larger surface. And I would recommend just doing a square object to cover that percentage. And then we can get you an idea of what kind of daylight access that space is going to get. Depending on how faithful the recreation of your skin is, the more accurate the daylight map will be, but the SDAs should always be consistent across all the different spaces. But the SDA or the daylight map will look a little different depending on how you modeled it. I just recommend don't going into too much detail, especially if it's more decorative. If you know like this type of envelope does block a certain percentage of daylight, just calculate the percentage of daylight and model that instead of the actual skin. But I'm not too familiar with that idea, so you might want to set up a support call or just reach out to our support team. Send us a screenshot and we can give you more information on that. Yeah. Cool, next question. I use the first Google link and it doesn't work. Sorry, Dylan, I'm still not sure what you're talking about. So the website seems to be working on my end. So yeah, feel free to reach out to us at hello.cotool or hello@cotool.com and we can kind of help figure out and troubleshoot what you're seeing on your end. Next question, will we be able to access neighborhoods in Canada for the analysis? Yes, so the 3D analysis that you see, or the context buildings that you see in the 3D analysis, this is coming from OpenStreetMaps. OpenStreetMaps is a global tool, so we have context information from almost any corner of the world. So you should be covered, and then all of the other information is also pre-populated. And some of our biggest international users include Canada, as well as Japan, Australia, UK. Yeah. Next to last question, is ASC calculated during operating hours, 8 a.m. to 6 p.m. like SDA is? Will these be editable in the future for projects that are operational 24 hours? So Keaton, SCA and ASC are both calculated during operational hours. So yes, operational hours are always 8 a.m. through 6 p.m. for a daylight model. You wouldn't need to calculate daylight after these time periods because typically you don't receive daylight for most places that we're seeing people use Cove Tool. In certain scenarios, I think it would be something we would look at, but right now we don't have any intention to open up the definition of operational hours outside of 8 a.m. to 6 p.m. So that's kind of the answer. Oh, cool. All right. So I'm about to cut off the webinar, so I'll quickly answer these two questions and then we'll be good to go. So Dylan, I've been requested to lecture about Cove Tool for my local simulation group, BSUG, but I can't reach the website and find the email address. Is there an email address I can use? I'm going to copy your information, Dylan, and I'll contact you directly. So don't worry about it. All right. And then finally, are weather files site specific or weather files from the closest weather station? The weather files are always from the closest weather station. That's the only place that they're recorded. So yes, but based on like what the nearest weather station is to you, that should be pretty accurate because there's not going to be too much of a difference from the weather where you're located versus your nearest weather file. There are some areas where there are blind spots, but you can also go to the Help Center, type weather files, and you can see a map of where we have weather files located around the US and around the world. Cool. It looks like it's all the questions. Again, thanks everyone for joining and staying a little later to hear all the responses. Hopefully you found it helpful. And thanks. See y'all next time. All right, bye everyone.